This is Module 9 homework for psychology. Fuck you. Alright. I'm just gonna speedrun this. I've tried recording this like a few times now, and I've given up. You're not gonna hold me accountable for anything, you're just looking to see how I do things. That's all this video is meant to be, believe. Normally distributed? No. It's not above 60. Yeah, see right there, it's too small, it's not above 60. Do we know standard deviation? No, we do not. No, we do not. Is it appropriate? I don't think so. We do not have reason to believe that sample mean is normally distributed, therefore it's not. So, okay, that. I got a freebie right off the bat. Are you kidding me? The 3 times I've tried this, this is when I get the freebie. Oh, whatever. I'm over it. I'm over it already. I don't care how depressed I sound. I'm really over it. I just had enough. How many conditions are there? There are 2. Naturally defined or experimentally defined. New cream, the advertiser knowledge, wrinkles, cream. Sounds weird. Okay, it is weird. This. Wait a minute. I have reason to believe this is experimentally defined, but if this is naturally defined, I swear to no taking chances. Okay, there we go. This is within participants. I already had this question a few times before. Basically, yeah, the same 81 women are going through the same treatment. This is what within participants usually means. Between participants, one group does one thing, another group does another thing. That's what between participants is. Match pairs, husband, wife, does the same thing. No, husband, wife, they do different things, but they're together. Like it specifically says that these guys are a pair. Are the measures taken on any one participant? No. What? No carryover effects. Continuous. How many measures per participant? 2. D. Hang on. Compute the difference for each participant between the 2 conditions. By subtracting condition 2 score from condition 1 score. So that's C. Wait. Nope, not C. D. Alright. Okay. Give me the juice. Is there reason to believe that the normally distributed? Yes, it's above 60. Does the experimenter have a hypothesis about the expected amount of difference between the number of wrinkles? No, they do not. Read the question again if you're not too concerned. Is it appropriate? Yes. Because we do not have... There are 3 things missing. In order to pull a thing, you gotta have no well, this is the only reason you can pull a confidence interval. No population standard deviation. The delta... sum of y is normally distributed, meaning it's above 60, and its thing is somewhat of a mound. And lastly, it's great. Both of them are greater than 60. You gotta have something like this. Okay, that's terrible, but fuck. You all know what I mean. Not a wave, a little hill or a little hump. Something generally like this. Enter the sample mean. Okay, so this is simple. This is straight up simple. Take this, divide it by this. Divided by 81. So you take sum of y and divide it by the number of pairs. Usually it's not laid out this simply, but we got lucky. Standard deviation. Oh my god. Okay. So this is the thing we have to follow now. We'll start with this, and we'll work our way here, and then we'll work our way here, and then we'll do the whole thing all together. Where's the damn calculator? So we're going to start off with 1466 squared divided by 81. We're going to take 2 minus 26 at 0.701234567901 23456790123. Holy moly, I have never seen a number that perfect after its decimal points. Okay. And now we got to square root the whole... No, wait, we subtracted the 2. Now we have to divide it by 80 and square root the whole thing. And now we got to put in the 6 digits. There we go, that's the correct answer. What is the estimate standard deviation? Okay, so all this is the SD divided by the square root n. Anything more? Nothing more. So we're going to take this. First, we're going to figure out what the square root of 81 is. I think that's 9. Oh, well, would you look at that? So 5.061 divided by 9. And that's our answer. And we need 5 decimal places, so we're going to take these 5, put them here. Okay, this legitimately drove me mad last time because I was not able to figure out the DF. Initially, I thought it was something, but it was not. So, what is the alpha? Wait, where does this question begin? Sigma 1. I want to try that first. 2.6395. This is what drove me mad the last time. Do you have the correct value of thing? Okay. Since we're calculating this, we have to divide it by 2. Do you have the appropriate number of degrees of freedom? Wait, don't tell me it's 80. I swear to God if it's 80. Okay. This is what drove me mad the last time. Okay, because of a question like this uniquely, the df was n minus 1. I'm gonna be mad if I'm not recording. Alright. Enter the lower boundary level. Confidence of 2. Okay, this is simple. This is more simple than it sounds. If I remember this correctly, this is sum of y minus the t alpha divided by 2, which was the value we just got, multiplied by the ESD. I'm having hope in my voice. I should not. I should have known any better. Gonna do my personal calculator. So 4/6x minus 6,387 multiplied by, what was that? 0.55756. The reason I'm hesitating a bit is because I also lost petty marks around this area. Okay, so it's that simple. So the formula is true. Now since we're doing this was all for LB. Now to avoid confusion, I'm going to do this in a different color. So, whoops. Since we're looking for this, we're going to add this entire thing. So T alpha divided by 2 times ESD. And this is all going to be for upper boundary. Wait, what happened? Wait, what just happened? I put in the answer, 1464.53. Should have told me that sooner. Hint. Sample mean difference. Okay, wait, is it the 18? I guess it's the 18. Let's find out. Oh, fan-fucking-tastic. I only need you, and you. My pitiful reminder. Is lower boundary sample mean difference. So I guess it's the 18. My mistake. I apologize for misleading you. 6,387 times 0.55. I don't know what happened. I clicked enter. Okay, so it is the 18. So it is this small little number here. So pay attention to whatever the small number here is. I don't care at this point. Point that plus 2.6387. Political party who would vote for the candidate held a thing tomorrow, so okay, it's 1. It's independent. Hang on, this would be binary because it's between 2 politicians. Measures 1. Is there a reason to believe that the candidate proportion? That's a huge sampling size. No, they did not. Yes. I mean, it's greater than 120. It's greater than 100, actually. Okay, so, oh, because this is a distribution, this is going to have to be greater than 100. What is the portion of people that's amount the thing? Okay, so in this case, it's just going to be a simple 940 divided by 1536. Total number of people voted, they would vote for the party's candidate. So this would be a simple 0.612. What is the estimate? Oh my, hang on. Wait a minute. For this one, it's going to be a little different. I forget how you do this one. What is the estimate standard population? How would you do this one again? I forget. You're not given the standard deviation, nor are you given the values. I don't remember. Oh man, I've done so many of those question 3 ones, I've forgotten how this one goes. Oh, right. Oh, how could I have forgotten? Jeez. So this one is just P times Q divided by N. We know N is that 1536, and so Q is just equal to 1 minus P. Oh man, I just needed a harsh reminder. 1 minus 0. So it's that 0.388 times 0.612 divided by square root. So that's the sample. That's going to have to be brought up to the 4. What the heck? Is it 0.1 or 0.01? Okay, in this case, it's going to be absolute value. Yeah, pay attention to that. That's a lower boundary interval. Why is that so small? That's annoying. The lower boundary interval is... Oh no, I forget already. No, I know for a fact it's this, so it's P minus Z divided by 2 times the SD. And then the opposite's going to be for the upper boundary, so it's simple. Okay, 0.162 minus, what was the Z again? 2.5758 times 0.012434. Oh wow. 8. Upper boundary, simple. 0.12. 0.612 plus 2.5758 times 0.012434. The same, right? This program is not forgiving. I don't like that one bit. Yeah, whatever. Get me to the next problem. Ah, great, another one of these. 82, 85. Oops. So that's what happened the last time. A psychologist wanted to know that... Okay, I already know the answer to this one is 2. This is experimentally defined. If a scientist is involved, 90% of the time it's experimentally defined. That's the 10%! According to his sentence, he lived greater than 80,000 and the population was less than 15,000. He also eliminated anyone who lived with... Okay. I get the feeling it's between participants. Usually I don't like to trust my gut when giving the answers, but that's usually how it goes. Continuous because it was arranged from -100 to 100. Measured once? Yeah, once. Is there a reason to believe that? Oh my gosh, okay. We scroll back up here. We're gonna have to follow this rule. So we need to take the first standard deviation. Sample means. Oh no, oh, okay. Well, okay, it's, instead of it going to be sample means, it's just going to be 1/4 greater or equal to then y1 squared over y2 squared equal to 4. If it breaks this range, it's out. Wait, we haven't even calculated the sample mean yet. Oh, it's normally distributed. Whoops. Forget everything I just said. It's greater than 60. And also has that rough mount. Do we know the... Not mentioned. Enter this, I thought it was suspicious. Sample mean for group number 1. Okay, 690 divided by 82. 8.4146. Okay. 159 divided by 85. 1.8706. Estimated. We do not know them, so we're obviously going straight for a t-test. Alright, we know what this is, so where's that one note? So we're gonna have to do this one all over again. So we're gonna do this, and this, then this, and then the whole. Look at that, it's a smiley face. But really, it's sad. Because it's gotta do this over 4 times. Anyhow. Okay, let's make this snappy. 690 squared divided by 82. Okay. I guess the annoying part is I gotta retype most of those numbers. 5006. 6.097 560 97560 560 97560. Hopefully I got every single one of those numbers correctly. Okay, now we did that. We did the subtraction between the two. Now we got to divide it by 81. Square root the whole thing. And holy moly. That's a 9. Oh my god, that's... Does it have to be this meticulous? Whatever. Just figure it out here. Uh-oh. 8, 9. I'm looking back and forth. Through my mind like a cigarette. Okay, so we're just going to repeat the whole process again. So 195 squared. What the heck? 195 squared divided by 85. Okay, so 38101 minus 29 42352941176 47058 8235 294116747. Divided all by 84. Square root it. Wow. That's a 7. Okay, now we gotta do that thing. Where is that? Now we gotta do this. So if standard deviation 1 squared divided by standard deviation 2 squared is within this range, it's acceptable. If it's not, you give it the big old X. Usually, this is not the case. We're not trained to do it that way. So, 14.49989 squared divided by bracket 21.214.270 bracket squared equal to, well, it fits within that range, so it's a yes, because this is in between that range, greater than 0.25 and less than 4. So, yes. Standard deviations are within reason. Okay, so let's see if it meets the criteria again. We don't know the standard deviation, so we had to figure it out. It looks normally distributed. Kind of. We established that before, and it's greater than 80. Well, it's greater than 60. That's all that matters. So, this is a good yes. Pooled standard deviation. So the pooled standard deviation is just this. Well, what happened? Okay. So yeah, this entire monstrosity. What I usually like to do is establish this one first before I continue. So I know a good place to start. So if I do this correctly from the top of my head, 82 plus 85 minus 2 is 165. Here, I'll prove it. 82 plus 85 minus 2. There we go. 165. And then I'm just going to do this entire thing and then divide it by 165. So don't be surprised when I just pull a 165 out of nowhere. And 1. Okay, I got to make sure the 2 are connected. You know what? You stay down. I know the formula. I know what to use, so 81 multiplied by bracket 19.499 squared. Yeah, you gotta add the thing. Plus 84 times bracket 21.214 207 bracket squared. So you add, everything looks good so far, divided by 165. That's a huge number. And then you square root the whole thing. Okay, I'm not happy with the way this turned out on this calculator, because the sample mean is not supposed to be this huge. So I must have done something wrong here. So I'm just going to do it on my other calculator, which I have in my hand and I cannot record as of this moment, just to make sure I did this process correctly. So give me a bit. $81 times bracket 19.998 squared plus 84 times, what is it? Reverse bracket 21.21 427 squared. Make sure the whole equation is correct. Divided by 165. And then, yeah, I fucked it up somewhere because I'm getting a completely different answer. So now I'm getting 20.39065. How many degrees of freedom? Okay, so all you gotta do, degrees of freedom. Yeah, that's all you need to do. Take that, subtract it by 1. Take that, 1, subtract it by 1. This is a previous attempt, but basically, n1 minus 1 plus n2 minus 1 gives you that. So, if we follow that procedure, 81, okay. 82 minus 1, 81. 85 minus 1 gives you that one. 84 plus 81, 165. And that should be your answer. So we already established 165. And then if we scroll back up, what was our alpha? 0.1, so 0.5 should be our alpha here. Get rid of a 0. Bang. Absolute 1.6541. Just make it positive because that's what absolute means, and I'm dividing it by 2 because, see that little 2 digits? Yeah. I've done this multiple times just to get that fucked up. Okay, so now what we gotta do is take this number, which is essentially this number, this last number you calculated, and multiply it by square root of 1 over n1 plus 1 over n2. So if I do this correctly, bracket 1 divided by 82 plus 1 over 85 gives you that. Now you got to square root it. It square root the first, okay, I can't work with this calculator again because it square rooted the first area and not the second one. So let me try this again. So I'm going to do this on a different calculator, but the procedure remains the same. The procedure remains the same, okay? So you're going to take this last number you calculated and you're just going to do that. Let's try this again. Okay, so I'm going to do it on my real calculator because this calculator does not want to cooperate with me. Fine, I'll do it again for you guys. 1 divided by 82 plus 1 over 85. Bracket Now just, okay. So now I'm just going to input this digit again. It's going to be tedious, but at least I know I'm getting absolutes. 9, 8, 2, 7, 8, 3, 3. 5, 7, 2, 4, 5, 3, 3, 7, 1, 5, 9, 2, 5, 3, 9, 4, 5, 4, 8, 1. So now we're just going to square root the whole thing, and that's our answer. See, where is this addition coming from? Okay, you know what? I'm just going to do it on my other calculator, because I don't understand where that's coming from. 1 divided by 82 plus 1 over 85. Okay, square root it all. Okay, we're going to take, remember that 0.1457 whatever? We're going to multiply that with the 20.39065. And so if we're going to take the last few digits, it's going to be 3.15626. Okay, now to find the lower boundary. Okay, because this, okay, if we're looking for the, okay, let's just get rid of that first. That's a 4, let me clarify. That's a 4. If anyone can't read it, okay? We're going to take the difference between these two because of the question's nature, and since we're looking for lower boundary, we're going to subtract. We don't need this. We don't need this. We're going to only follow this formula. Okay, so you're just going to subtract these two. So let's see if I can do it on the calculator. 8.4146 minus 1.8706. Okay, we found that. Minus the multiplication of those two. So it's going to be minus the t square. What was the t square? Okay, minus 1.6541 multiplied by, so, and then we're going to do it with this last digit, so the 1.35626, and that's our thing, 1.32. And then the reverse is going to happen, so it's just going to be the addition. So if we go back here, so we're just going to remove this, and since we're looking for upper boundary, it's just going to be plus or UB. And that's why I had it previously before, where it's like that. So positive, if you want positive, UB, you add it. If you want negative, it's LB. But since we're looking for positive, we're just going to try and switch that. So we're just going to re-enter it. 644 plus 1.64 times 3.15626. And that's our final answer. Oh boy, here comes the final answer. Our final question. How many groups are there? There's one. Is it independent? Yes, it's independent. Continuous. I remember this because I briefly saw negative 100 to 100. What are the measurements of participants? University student to ask them. Oh, this is the immigration one. He only took one. The reason to believe, I say no. Because, I mean, it does have the moldy shape and everything, but... Oh, well, never mind. It is the moldy shape. It's because of the moldy shape. I was about to say it's not greater than 60, but who am I to judge? Do we know the population standard deviation? Again, we're not given that. Do we know the hypothesis for immigration? Usually no. Okay, whenever I say the word usually, I'm really scared shitless. Okay, if we go back to confidence interval, we do not know the standard deviation. It's normally distributed. It's not above 60. So I'm going to try no. It's yes. Fuck that. Where's that bitch? Red? There we go. What's a sample mean? Okay, that's simple. 1103 divided by 56. How many decimal points? Let me just click out. Perfect. Are you... No. You round it up. You round it up. This is salty, man. This has gotten very salty. Sample standard deviation. I forget how you do this again. I know we just did it a few times. Oh, wait, no. No, wait, it's not this way. How did we do it before? Because we just did this question a while back. We're given a sample. Oh, it's right there. It's right there. I didn't notice it, but it's right there. So yeah, we're going to use this formula again. Let me get it black again. We're going to use this formula again, just like we have done a couple of dozen times already. So, yay. Squared. Let's keep... Oh my god. Okay, you gotta be an absolute C for that to work. Stay that way. Divided by 57. No wonder it didn't work last time. So we squared it. We divided by 57. Now we gotta subtract this whole thing by 3761 minus 21344.01 543569641228070175436. And then we square root the whole thing. No, I fucked up. I'm sorry, guys. I fucked up. We're going to take this whole number. 616.928. I'll tell you exactly why I messed up so much. 3508 771929 82614. We gotta divide it now by 56, which is n minus 1, and then we can square root it. Oh, I missed a decimal point. Okay, you know what? I'm not gonna type that again, but you get the idea, okay? So I'm just gonna repeat everything on my other calculator. Squared divided by 57. We're gonna take 37961 minus answer. Now we're going to divide it all by 56. Square root the answer. Man, doing it there is faster. Why haven't I done it on that? 22590.6. It's estimated. It's never been... The reason we're doing this is because we're estimating. We do not know it. So okay, the degrees of freedom. So this is just n minus 1. So this is going to be 56. Okay, okay, wait. Degrees of freedom, we've already established this was 56. 0.01. We're good where we are. And since this is absolute, it's just 2.6665. The S Wait, no. Wait. I hope this is what this means, because then it would make no sense. Okay, so we're gonna take sample 1.22509 divided by square root bracket 56, no, not 56, 57 square root. Okay, I'm gonna do this on my calculator just to be safe, because I don't want above 10 errors, because if it goes above 10, I'm just instant. Oh my gosh, I'm giving myself my own little mini heart attack. If you guys don't remember, this is how you do it again. Okay? Well, it's not this. This is wrong. This is wrong. It's just whatever the sample mean is. In this case, it just so happens to be y for this question, so never mind. So in this case, it's 19.305 minus, what was the t-score? 2.6665 times, what was that random arbitrary number? 2.28163. It was the last number you computed. So this should be the right answer. Correct. This hasn't gone up. Okay, now we're just going to add 19.350 plus 2.6665 times 2.28163. And that's our final answer. Fuck that.